Hi, how's it going? Welcome to Code with Z. In today's video, we gotta find this word inside of this matrix that we have here. Why? Well, because that's what LeetCode 79 word search is asking us to do. As you can see, it says, given an m by n grid of characters called word. So this matrix that we have here is called word, and a string called word. For example, this string that we just saw here, return true if the word exists inside the grid. And here it says the word can be constructed from letters of sequentially adjacent cells where adjacent cells are horizontally or vertically neighboring. And also the same letter cell may not be used more than once. So let's see what this actually means. Let's first bring this down here and let's get back our word. So for example, if we were looking for this word inside of this matrix, A, B, C, C, E, D, we can see that it exists. Why? Well, we have A, B, C, C, E, D. And as you can see, these cells are either horizontally neighbors or vertically neighbors, and we've only used each letter once. We used A once, B, C, C, E, D once. So let's see how we can solve this. Well, first of all, no matter what word we're given, we need to start from somewhere, right? And that somewhere is gonna be the first letter of the word that we are given. So before we do anything, we first need to see if the first letter actually exists in the grid. If it doesn't, why even bother to find how we can actually construct these letters together? Because the first letter doesn't exist, so it doesn't make any sense, right? So the very first thing that we need to do is to look through this grid or matrix that we have here. So when we actually run our search to loop through all of the cells that we have here, we can see that we actually have A, which is the first letter of our word. So now we know that we can actually start from somewhere. So we're gonna be like, okay, we found A and this is gonna be our starting point. From this point, we can have 4 possible directions because again, remember, we need to construct the letters together until we find this word that we have here. Our 4 possible paths are gonna be, we can either go right from A, we can either go down from A, we can either go left from A, or we could either go up from A. So now we know we have 4 directions and we gotta check them one by one. But before we do anything, we gotta make sure that we mark A as visited. Why? Well, because we don't wanna visit the same cell twice. So we're gonna change the value of A to this so we can make sure that we don't visit it again. And this is gonna basically mark it as visited. And then we gotta see how many of these 4 paths we can actually explore. Well, if we check, we can't go left or up because we have to stay in this grid that we have here. So these 2 are literally out of bounds and the only 2 available options are gonna be these 2. Now we're gonna be like, okay, we have these 2 options and our next letter that we need to find is gonna be B, as you can see, and we're gonna explore these 2 paths. When we explore them, we find out that B exists in this path. So we're gonna be like, okay, this path is also incorrect. So the correct path is gonna be this one, like so. When we reach B, we know that we have to keep on exploring because we know we don't have the word yet. The length of our found answer is currently 2, but the length of the word that we need to return is 1, 2, 3, 4, 5, 6. So 2 is not equal to 6, so we're gonna keep on exploring. When we wanna keep on exploring, we're gonna be like, okay, first let's mark B as visited, like so. And then we're gonna be like, the next letter that we need to find is gonna be C. So let's see how many actual paths we have out of this 4. Well, we only have 2. Why? Well, because we can't go up or left because we've already explored left as well, and up is out of bounds. So we can either go right or down. And when we check these 2, we're gonna find out that the correct path is gonna be C because F is not equal to the letter that we were looking for. And then we're gonna be like, awesome, now we are at C. Let's mark C as visited because the current length is 3 and that's not equal to 6. So we're gonna keep on exploring. We're gonna be like, okay, our next letter is gonna be C. Now we have to check how many actual paths we have. Well, if we check, we only have 2, right or down, because we can't go left because we've already been through that cell, and we can't go up because it's out of bounds. So we're gonna be like, okay, we can explore these 2. And when we actually explore it, we find out that this is incorrect and we can only go here because this is the letter that we're looking for. When we actually reach this, we're gonna be like, okay, we still don't have the length that we're looking for. Currently, we are at the length of 4 and the word that we're looking for is 6. So we're gonna keep on exploring. We're gonna mark this as visited, and then we're gonna explore our actual paths. And the next letter that we gotta look for is gonna be E. So let's check. We can either go left, down, or right. We can't go up because we've already been through that cell. And when we actually explore, we find out that these 2 are incorrect and we can only go down. So E is going to be the correct answer so far. We're going to reach E, and then we're going to be like, we still don't have the length that we are looking for because the length that we currently have is 5, and the length of the word that we have to actually find is 6. So let's keep on exploring. Let's mark this as visited. Let's see how many actual paths we have. The next letter that we need to find is going to be D. Let's see how many actual paths we have. Well, we can either go left or right because down is out of bound and up is a cell that we've already visited. So we can either go left or right. And when we check, we know this is going to be incorrect because the letter that we look for is D. So we're going to come here and we're going to reach D. When we reach D, we're going to be like, okay, the length that we have is equal to the length of the word that we were given. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's awesome. That means we have an answer and we're going to return true. If we didn't find an answer, we're going to return false. Now, let's code this in the simplest way possible. Alrighty, let's code this together. So the first thing that we need to do is to find the first letter of the word that we are given. For example, the A that we had. So we're going to loop through our grid to find the first letter. So we're going to say for let row being equal to 0, and we want to keep on looping as long as row is smaller or equal to board.length minus 1. This is going to be the number of the rows that we're going to have inside of the given board or grid that we are given. And we want to increment row on each time. Then we're going to define another loop because we want to loop through each cell. So we need to have a nested loop. We're going to say for let col being equal to 0, and this is going to be representing our columns, and we want to keep on looping as long as column is smaller or equal to board index 0 dot length minus 1, and this is going to be representing the number of columns that we have, and then column plus plus. Here we're going to be like, if the letter that we're currently at inside of our board, so row column, is equal to the first letter of our word, that means we actually found a starting point. If that's the case, and this function that we're going to define in a bit, which is called backtrack, because our approach is going to be recursive backtrack, the approach that you saw in the slides was recursive backtrack. If our backtracking function that we're going to call with the row and the column that we found that has the first letter inside of it, and with the index of 0, don't worry, you're going to see how our backtracking function is going to get implemented in literally a few seconds. If this also returns true, that means we have an answer, so we want to return true. So what this is saying is that if we actually find the first letter of the word inside of our board, that means we can actually call our backtracking function at that point. And if this function at the end returns true, that means this statement is true, so we want to return true, because that means the word actually exists inside of our board. And if that was not the case, we're going to return false. Simple as that. Now let's define our backtracking function. So function backtrack, this is going to take a row, a column, and an index, and you're going to see why. The row and the column are going to help us to get the letters that we have here. So for example, when we said we go right, we need to increment our column, because going right from this position means that we stay in the same row, but we're going to change the column from this column to this column. So when we actually say, okay, we know B is the correct letter, and let's explore right and down, we need to update our row and column values that we have here to actually explore these letters, because, for example, C is in the first row and the third column. So if we want to get C, if we want to access C, we need to have a row value and a column value. And this index here is going to be the index of the word that we have. So each time we were like, okay, we found A, the next letter is going to be, for example, B. So now we need to look for B. As you can see, this index is going to be giving us access to the letter that we need to be looking for each time we find the letter. So it's going to get incremented. So now let's implement this. We're going to first say if our index is equal to the length of our word, that means we have an answer, so we only need to return true. And we were checking this every time in our slides as well. We were like, do we have the same length as the length of our word? If that's not the case, we need to keep on exploring. And when that was the case, we actually returned true. Then we need to make sure that we only explore the correct paths. So for example, we can't explore a cell that's out of the boundaries of this board that we were given. So for example, we can't go here, up here, or like down here. We need to stay inside of these borders that we have. So we're going to say if row is greater than board.length minus 1, meaning if we've incremented our row number so many times that now it's bigger than the maximum rows that we can have, meaning it's pointing to this position here, return false. But this is not going to be the only case. We also want to return false if our row number is smaller than 0, meaning it is pointing to this position here, up here. Let me drag this to the left. Awesome. And this is not the only case. We also want to return false when our column number is actually greater than the maximum column number that we can have, like so. So for example, if our column number is pointing to this column, but the maximum column number that we can have is going to be this one, we also want to return false in that case because that's going to be invalid. Or when our column number is actually smaller than 0, that's also false. We can't have a column here before the first column. These are all invalid paths. And there's also one other case, and that's that if our board at row and column is not equal to our word and the index that we have, we also want to return false. Meaning, for example, if we are at E and we know that we need to find C, we want to return false because we know E is not the correct letter that we need to have at this point. So this is what we're saying. We're going to be like board at row and column. If it's not equal to the word at the index that we have, we also want to return false. And this is going to take all of the cases that we need to return false. If we actually don't return false or true, we're going to mark the row that we have and the column that we have as visited, like so. And then we're going to explore other paths. We're going to say if backtrack. So you have to call the function again in all 4 paths. We're going to say if backtrack at the next row, but same column and index +1 because we have to increment index on each round. If this was true, return true, like so. But that's not the only case. We also want to return true if backtrack at the previous row, same column, index +1, returns true. What we're doing here is that we're going to call our function in all 4 directions. And you might be like, how do we know that we're calling it in the correct direction? Well, this is going to make sure that we return false if we actually go through the wrong directions. So we don't need to worry about that. All we need to do is to call our function in all 4 possible ways. So we've actually called it when we increment the row, when we decrement the row. Now we need to do the same thing for the columns. We're going to say same row, this time next column and index +1. And then the last one is going to be backtrack, same row, previous column and index +1, like so. Our last line is going to be that we're going to restore the value that we changed, the letter that we changed to its original value, like so. This is going to be all of it. So we first mark this as visited. We're going to explore our paths and then we need to restore the value. So let's run this. I hope I have not made any typos in these lengthy lines. And awesome. Let's submit this and see if we can actually pass all of the test cases. And moment of truth. Yep, that's awesome. We got accepted. Thanks for watching. Don't forget to like and subscribe and keep on coding.